Well, hello and good morning, and thank you for joining me in my shop here on August 26th. Oh my gosh, almost the end of August. Another gray day here. Hopefully some sun later in the day, but maybe not. So here I am with another radio. Now at the end of the last video, if you're watching videos as I post them, then you heard me mention something about a generator, doing something with a generator. It's going to be a little while before I do that because the generator is buried under some stuff. It's a lot of work to get to it. It's not a huge thing. It's about this big. But, so instead, we're going to do another radio. I've done a series of small radios like this one. This is actually not as big as it might look on camera. And we're going to have a look and find out about this radio. It's got a knob on the back. It says loop versus antenna. How do you like that? That's a little unusual. Put a switch there. So, Mohawk radio, New Toronto, Canada. New Toronto. Never heard of New Toronto. Don't know what that is. And give a model number here. Model number 1240. A Mohawk radio. I don't think I've done a radio with the brand name Mohawk before. Let's look at the front of it here. Well, it says Crosley on the front. So back in the day, there were a lot of sort of background manufacturers manufacturing radios that were coming out under different brand names. This just talks about the licensed by the Canadian Radio Patents Limited only for the non-commercial reception of public radio telephone broadcasts. Patented 1913 to 1930. Inclusive. 1930. Mohawk Radio Limited, New Toronto, Canada. Huh. Well, it doesn't mention Crosley at all on the back here. Warning. Any person installing or operating this radio receiving without having first obtained a license. A private radio receiving license from the Minister of Marine. The Minister of Marine of Canada. Well, I've never heard of such a minister. Marine? Yeah, Marine of Canada. Is liable to be prosecuted and sentenced to a penalty not exceeding what does that say there? Not exceeding, maybe it says 20. I'm going to take a look. How big a fine you're going to get here? 50. Not exceeding $50 and costs, or 3 months of imprisonment. Ottawa, 16th of June 1932. This is an older radio than I realized. Tube layout, model 1240. 1240. There's a switch here for the loop antenna or the antenna, but where do you hook up the antenna? To this? I don't think so. There was once a wire hanging out of here. Probably the case. Okay, this is older than I thought. It's a nice style of wooden cabinet. You see like how the wood grain is going like this and then like that. It's a nice cabinet. It's in rough shape though. It's had some serious damage done here where the surface is gone. This is poking out. So, I'm not a woodworker. Pretty tough for me to fix something like this to look just like it should, but I can probably get this to disappear from view. The rest of the cabinet, in terms of like major structural type damage, I don't see any. These wooden cabinets were usually very, very well built. Sometimes they're coming apart in the corners. Now, the antenna. Is the antenna on the back? It does not appear to be mounted to this back. Let's take this back off right away. big screwdriver. So I'm going to have a whole bunch of these wooden cabinet radios. Oh, there's something written on here. You can see it better than I can in the camera. S1432, is that what that says? And it said something here, they've scratched it out. There's a selection of screws screwed into the back of this radio. That would tell me it's been on a journey. It's been places. Now, at least these get to my bench here. Like this is probably, let's guess, 2023? Let's say it's 1933. So that's 90 years ago. Oh, this screw is damaged. Oh no, it isn't. No, it isn't. 90 years ago. What's it been doing for 90 years? You know, all the stuff I've done. I haven't been around for 90 years. What have you been up to, Mr. Radio? Where you been? Who are you seeing? Talked to anybody recently? So, is this? Well, it feels like this is attached to the, these rivets. These rivets are going to attach the back right to the chassis. So, as usual, I want to take a look inside the radio before I plug it in, but I bet you we'll be plugging this guy in pretty soon. Two holding screws. Look at this, the wood comes right around. The pattern comes right around. Usually there's a flat piece on the bottom here, but they've actually brought this right around. Aren't you something special? Now, that's an interesting question. How special would this, what are these? Oh, these are what's left of the feet. Nothing left of the feet. So this guy would be in a store competing with other radios. What would make somebody want to buy this radio? Whoops. Do I not have the right size here? I do not. Okay. Well, it would amount to the look of the radio. Maybe the size of the speaker, size of the radio. Size of the radio would be a big thing because they'd be looking for it to fit in the circumstances in their home. So they'd be looking for a table radio or something like that. Tabletop or floor model or something. Boy, I'm just making sounds here with my voice. I'm not saying anything useful. Ooh, ooh, ooh. Oops. Sorry about the sharp sounds when I drop my tools like that. Is that a smaller screw? No, there you go. Yeah, it's been a strange summer. The first part was really nice. Sunny, warm. This last part's been gray. Cool. It's cool outside too. It's not terribly warm. Here we come. Here it comes. Yes, this is definitely an older radio than I realized. Oh my gosh, talking about a little bit of asbestos in the radio. Oh my gosh, it's full of a huge asbestos sheet here. Wow. And nothing on the floor, just the walls and the ceiling. I've never seen that before. My gosh. Asbestos, the wonder material. A lot of asbestos supplied by Canada, out of Quebec. Okay, so something a little bit interesting about this dial is it's got a pointer this way and a pointer that way, and then it's got the scale, and it's got another scale. But if you look, it's the same scale. It's the same pointer. Exactly why they bothered doing this, I don't know. To confuse you into thinking there's two bands in here, I don't know. It's just a lot unusual. Once in a while they'll put like the frequency up here, and they'll put the meters down below or something. They didn't do that here. So, and this clearly there's a bend in this pointer because we're pointing 120 here. We're not pointing 120 there. It's now become an issue during the alignment process. Now, if we look at the top of the radio, it's got all its tubes. It's got this odd tube shield. Why such a tall tube shield? The tube way down in there. 3 of them shielded. And filter capacitor. 2 IF transformers here. Top tuned by trimmer capacitors. And the trimmer here and one here mounted right on it. I think this one would be this, I'm just guessing, this is a series trimmer, and this is a parallel trimmer here. That's how many tubes? 1, 2, 3, 4, 5, 5 tubes. No transformer. You see the antenna is mounted to a wooden post here. There's a crack in it. The antenna is not on this back plate at all. Okay, let's take a deep breath, and we're going to look underneath here. Very light. It's a very light radio. Put my thumb through the speaker there. That was close. And we see, well, offhand, it looks like nothing offhand has been done to it. Let's just look more carefully. And big resistor here. Got wax capacitors all through it. Large one there, another one there. No sign of any work, although this cord definitely looks new. Interestingly enough, the switch is looks like a double pole switch here. Ooh. Yeah, doesn't feel too good, but we'll see. This is probably your basic. It's your basic 5-tube AM radio. It's just an earlier version. Here's the antenna wire up here, which should have been protruding out the back, but it's just left coiled up here. You can see it come in right to there. Now, normally you'd really want to use the loop antenna and not try a wire antenna. Normally, which is no normal anymore for these radios. Well, it doesn't look like it looks like I could start this guy up and see what it does, because I'm always very interested in making radios work as quickly as possible. Have as little work as possible, no work if you can even do that. Wow, and if it's all original and the radio works fairly well, nothing wrong with it, I'm inclined to leave it with all of its original parts. That's almost never happened though. I don't know, has that ever happened actually? The speaker's in good shape. This just doesn't look like something from the 1930s. So it's possible it's been changed? I don't think so. Look at this. It has a field coil. It's another sign that this is out of the 1930s. And this tube actually has a sales sticker on it. That's unusual too. They get way back. This tube, new. Oh, it's got the date on it. August 5th. No, that's got to be a year in there. 41. August something or other /41. Alex Guinane radio service, 9 Laxton Avenue. Does that say Los Angeles? LA? No. This is a phone number. LA0113. So when I was a kid, my phone number was Logan 7653. Actually, it was Logan 3 7653. So this LA, the L and the A are actually indicating the first two numbers of the phone number. There's only six digits here, so I don't understand it. But I'm pretty sure that's what that is. Phone number. Laxton Avenue. Now we can see the actual manufacturer is Rogers. So today, many of us, including here in my house, we use a internet service and TV service, cable service from a company called Rogers. It's the same company. This is what Rogers was doing back then. They were making radios, maybe not this one, and they were making tubes. Here's the actual tube number, 35Z5, same as the last two radios I've worked on. So the idea is, this guy could sell more tubes because he was willing to guarantee them. And the way he guaranteed them is he put a nice sticker on it and write the date on it. If you brought this tube back to him, let's say in 6 months, and said, look, the tube's dead, he'd depreciate, is that the right word? No, he'd deprecate. He'd reduce the price of the new tube based on the loss of life of this tube. So maybe he guarantees these for a year, and if it blows in 6 months, then you're going to get a 6-month reduced price on the replacement tube. A lot of sellers were doing this with their tubes. If you go back, like this is from, if this is true, 1941. That's not normally the range at which you find these stickers. It's much earlier. Let me look with the magnifier here and just see if I can see. Well, I'd guess it's August 5th, 1941. I can't make out any other date other than 41 there. So tubes were very unreliable in the earliest of days. So if you go back to the 20s, and tubes were coming out of the manufacturer, they're very unreliable, and so people didn't want to buy them because the tube would fail so quickly. So that's where this sticker thing came in. Okay, dwelt a lot on the sticker. Shall we start this guy up? So another just interesting thing is the RF tubes are shielded. The audio tube is not. No surprise there. Okay, so we're going to start them up. Now, I don't know the history of this radio. Don't know what the last time was it was operated. The switch on it is wonky. Let's start with it switched off. I'm going to be running the power. I feel I have to explain this a little bit every time I do it. Running the power through these light bulbs here. These two light bulbs. And that's to restrict the amount of current supplied to the radio, or voltage, however you want to look at it. And at the same time protect things. If there's a really bad short circuit in here, which I highly doubt, then what's going to happen is the light bulbs are going to come on fully bright, stay that way, and I'm going to know right away something's gone wrong. On the other hand, if things are proper here, what should happen is the light will come on bright, not bright, but it'll come on visible, it'll go down, maybe even right out, can't even see it, and then as the tubes begin to conduct current, the light will come up again, but you may not see it. It may not come up enough to see. Okay, switch is off, nothing should happen. There we go. So you may have seen this meter go right over. 125 volts. I'm just going to crank this down a little bit here. Voltage will drop on these bulbs no matter what. So the set is not going to get the full voltage. The full voltage right now I set to 114. It's probably going to get about 95, or it'll come to 95 or something like that. Okay, so I'm not going to operate the switch. I'm going to turn the power off. I'm going to operate the switch. 2 clicks in it. 2 clicks in the switch. The volume's right down. Now, what may happen now, when I apply power, I may just hear a big hum come out of the speaker right away, or the set may warm up and then hum. Here we go. Okay, first thing to check is, so the lights did not come on. I see the tubes are warming up. So if you see one tube warm up, they're all going to warm up because they're in series. Here comes the radio. Okay, that's a buzz. Let's turn the volume up. Sure sounds like a radio to me. Not a lot of volume. A little bit of a hum there. It's more of a hum than you can hear because it's got no cabinet on it. You can't hear the low hum. A little hummy. Okay. Will it receive? So here in my shop, the best place to try to receive is at 590 down here. But who knows how accurate this pointer is. Oh, it's definitely a radio. It's one of my typical interferences I hear in my shop. You can really see the curve in this pointer. Probably can't do anything about that. How come it got so quiet? That's full volume. Hello, hello. Not much happening down here. What if I boost the antenna? Ooh. She's pretty quiet. Not in good operating order at all. Those interferences, they all sound similar. Sounds like a garbly thing to me. Much louder at the high end. Nothing up there to receive. Okay, do I want to operate the switch? Okay, that was a bad show. That was a bad showing. I'm going to think about this a little bit. Drink some coffee and think about what the next step should be with this radio. Okay, after a little bit of thought, I think probably the next wisest step with this particular radio is to test the vacuum tubes in it. See if there isn't a weak one that's making it unable to receive stations or what. So let's start with, start with this one. Start with the rectifier tube. Which, you know, the guarantee is still there. I can still find this guy, Alex Gwinnane. Alex, I'm coming for you. Okay, I'm going to set up my tube tester over here and we'll put it to work. Okay, looks like I'm doing this in a sunset or something like that. So this is definitely a 35 WZ. Just making absolutely sure. 35Z5. Okay, we'll check the setup here. 35Z5, so 35 volts. No need to set it, no need to set it. And 07003. 07003. 0610. 0610. I can't quite see that. A little dark here for me. 23, that's what I've got, 23, and the plate is on E. Okay, we're ready to go. Now, I mean, we've heard the radio operate to some degree, so there's really little chance that this tube is bad. Warm up there. Okay, check for shorts. I'm stepping in front of the light here. Watch the meter. Nope, all is normal. And we're going to operate this switch, rectifier. A good rectifier will pass my finger on the dial here. Here we go. And it's way up there. Just fine. Okay, good shape in fact. So that was the rectifier tube. Now we'll do the output tube here. The output tube's either a 50L6, yeah, 50L6. Or I was going to say it's either a 50L6 or a 35L6. I'm going to leave the video going. 50L6. We set this to number 47. We set the signal level to 8. 18H. There we are. 07345. 07345. 0610, 0610, 43, and C. Plate selector. There we go. Ooh, should we double check? What can happen is you can very easily read the wrong line here while you're going across and start putting in the values for a different tube. It's very easy to do. 07345. 07345. Yeah, I think that's okay. We're good. There we go. You're seeing some flashing here on the tube. It's because that thing is swinging up there. Okay. Check now for shorts. Watching the meter. No shorts. If the tube were shorted, I'm pretty sure we would have big trouble when we tried operating the radio. This tube should reach at least 1030, it says here. So 1000's right there. So above where my finger was. So, you know, it's not the greatest tube in the world, but there's no way that this is going to stop the radio from operating. Might result in reduced volume a little bit. Okay, next tube, I'm going to have to get it out of the tube shield here. Okay, the next tube is actually the first tube in the radio electronically. It's a 12A8 with a grid cap. It has this interesting little piece on it here. It's wrapped around the center post, and then it's contacting this pin. This is pin number 1 here. So what they've done here, I believe, pin number 1 is not used, I think, in this tube, I'm going to guess. And they've hooked up pin number 1 inside the radio chassis to B- or to the chassis, one of the two of them, probably B- one way or another. And then they want that connection to be made to the cover here, to this guy. And this is probably, I don't know if feels like steel. Feels like steel to me. Plated steel. It's in pretty good shape. Well, they didn't want to solder to this. This has to be grounded too. This has to go attached to the B minus or to the chassis. Probably the chassis. But we haven't studied the schematic yet. So when you slide this on, it comes into contact with this spring-loaded piece here, which means you have to be careful about how you do this. I'm not going to slide it on now. And then that makes contact with the pin, and the pin inside the radio, the socket is, pin number 1 in the socket is going to, as I said, B minus or to ground. I haven't seen this before. Another indication this is an early radio. We don't need to do anything to test it special. We can just leave that sitting there. So I set this up. Yes, I did. And we're on 12 volts. Nothing too bad can happen. And we have to put the grid cap on. There we go. Now most of the time the caps on the top of these tubes are grid connections. Low voltage, safe, shouldn't worry too much if you touch it. Some of them though are actually plate terminals with high voltage on it. This would be the plate cap if I needed it. So, okay. Any shorts in this tube? Once again, it's very so in position number 1 it's come up a bit. Now sometimes there's a special note, 12A8. So all it says here is grid cap, and you're testing the whole tube when you do this test. Okay, I'm going to tap the tube a bit and watch this meter very carefully. Why this isn't right down close to the 0 or right on the 0, I don't know. It's very, very solid though. It's not like a loose component or something. Huh. I've never had this happen either before. Usually when a tube is indicating a leak like this, this is operating as an ohm meter right now. It's showing a resistance of around 2 megohms or so. So between two components we can figure out which two it is if I looked in the manual for this and looked at setting number 1. It's a specific thing like cathode deheater or something like that. It just doesn't change at all. That's my coffee break warning buzzer to make sure I don't miss my coffee breaks here. Well, let's give it the test. If this were way up here, then I would reject the tube. But with it so low, or high resistance, so this tube should come up at 700 and I believe that's 50. So 750 is only about there. I mean, it's halfway there already. Okay, here we go. Oh, nothing happened. Nothing happened. Something's going wrong here. Oh, I know what's going on. I left this over here. That's what's going wrong. Okay, we'll try it again. 7. Like I didn't blow my tube tester up. 730 or 750. I can't tell the difference, but it's going to be right around here. Okay, well, unless we get some other indications of trouble with this tube, I'm going to assume that that was a normal test and that reading we got is not of any consequence. I'm going to move on to the next tube here. Okay, so this tube is a 12K7. And you might be more familiar, if you're fooling around with these radios, with the 12SK7. It's the same tube, except the grid cap has been relocated to one of the terminals underneath. So there's no grid cap. So the S in 12SK7, the S stands for single-ended, not double-ended. That's what's going on there. So this is the early version of the 12SK7, you could say, or has the same function, the same 12. So let's just double check. Okay, so signal level 2. The bias is 33L, 17342, 17342, and 0610, 43 D. There we go. This is probably the IF amplifier. This is probably the tube that's responsible for most of the gain, the RF gain, in a set like this. Okay, here we go. What are you going to do? Oops, I got over to setting number 1. It just fell right down. That's normal. All normal. This one should test just above 1,000. 1,000 is here. Just above. When I say it should test just above, if it tests any lower than that number, you should be selling a new tube to your customer. That's the idea. It's above. It's good. Okay. That leaves only, I think, one more tube to test. Okay, next tube is a 12Q7. Again, 12SQ7 would be the same thing, but the grid cap would be one of these pins. 12Q7. Okay, 12Q7. 13. Signal level 1. 23L. Right on. 27300. 27300. 0610. 0610. 48. Ooh, what did I do wrong there? Oh, no, 30. 30's right. And F. Okay, let's put them in. So this is 2 tubes in one, and it's going to get two different tests. One part of this tube is an audio amplifier. Takes the weak signal coming out of the RF stages of the radio just after detection and boosts it up enough that it can be applied to the grid of the output tube, and you can get a strong output from the output tube. You need a fairly large voltage swing on the grid of the output tube to do its job. The other part of this tube is 2 diodes that are in there that are used for rectifying the RF coming out of the IF stage. Okay, any shorts on this guy? Nope. So that mysterious thing on setting 1 on that other tube remains a mysterious and lonely thing. Okay, in this case, we should be getting 780, which is about here. Past my finger there. Yeah, good. Okay. Even if it were at 780 or a little bit below, I wouldn't write this tube off because, to a large degree, tube testers were to help tube sellers sell tubes. Just because it doesn't meet this particular standard doesn't mean it's inoperative, but it would mean it was weak. There's no doubt about that. Now we got to do the diodes. I'm going to pull this out while I make these changes. So we don't care about that. We don't care about that anymore. 2703P. 2703P. Yeah, if you have enough coffee. 0610. 0610. 48. P1, P2, plate 1, plate 2. We'll put this back in. Give it a chance to warm up. Now in this case we're going to be flipping the diode switch here. And where rectifiers are okay up in this area, diodes only have to make it up to here on this tube tester. And it's good. Okay, we'll check for shorts. Always good to check for shorts, because to some degree you're protecting your tube tester from testing a shorted tube. And we're going to put that switch, here we go, just above here. Way above here. Now we flip to the other plate, pushing the P2 switch. It's also right up there. So all the tubes in this radio tested good. And yet it's not receiving so well. Well, there's a few more things we can pursue. I don't want to just jump in and start changing capacitors without having some notion about what's going on with the excuse me, with the radio. There's a big blob of solder there. This one comes with a metal base. I don't know for sure. Is this metal base is connected to pin 1 and pin 1 is grounded internally in the radio? I guess that's what's going on. This may have come from another radio because it doesn't match the other shields. And look at how tall it is. It's a little kind of going a little far here with this little tube. So I don't know where this has come from. Of course. Stick it on there. Put the tube back in. Put on the grid cap. Now, one thing that is possible here is there was a tube not making proper contact in its socket. Bit of a long shot, but I think we should test this radio once again. Okay, can you come up a little higher? Not too much. Okay. So the switch is off, power is off, plug is out. Plug in. Turn the switch on, and then I'm going to apply power. There we go. There, you can see that light come up. That's the rush current going through the cold heaters. The heaters warm up quickly and the current drops. And now if the bulb starts glowing again, which it may or may not, looks like it's not, but if it did, it would just be reflective of the fact that the radio is drawing a little more current because now the tubes are drawing current. Do I expect any difference here? Not really. No. I think it's a long shot, but so it's really dead in this part of the band and doing something up here. That sounds like an alignment thing. So what we're going to, now this has come to me from someone like me. So there's a good chance this radio's been worked on somehow. I noticed none of the capacitors were changed in it. So it's possible somebody did an alignment on it. The previous guy did an alignment. So we're going to try to find out if that's the case. How would we do that? We would do that by starting with coffee break. I almost forgot the coffee break, even with the alarm. Coffee break time. Okay, I think the first thing I'll try is feeding a kind of a regular radio signal out of my signal generator there into this coil. This is just some wire. It's nothing special at all. This is the lead from the signal generator. Just putting it near the antenna to the radio. And right now I'm feeding a signal 709 kilocycles. We'll turn on the radio here and see if we can pick this up. So 700 is going to be right around here. This is in the quiet part of the radio. It's already weak down here. See what we can get. Yeah, in fact, I'm going to move up here where we know the radio appears to be more sensitive. Okay, so I'm going to dial in 1500. Okay, and we'll go to 1500. So that's a pretty low signal I have it set to right now. Didn't hear a thing though. Let's go higher. Okay, so that's 100 times stronger signal now. 1500. That's a pretty bad showing. So just varying the modulation from 1000 to 400. Can't hear a thing. So let's give it a boost, 10 times stronger yet. This is a very strong signal going into this loop. So any radio should be picking this up loud and clear, really loud and clear. So here again, it's a garbled sound. It doesn't sound like a pure tone. It's garbled. So that suggests 60 cycles or 120 cycles, he says quietly, getting into a place where it shouldn't get into. That's how I would describe this. Okay, so that's surprising because it seems to pick up noises fairly well. Let's go down here. Now we'll try it around 700. We'll see what we get. So you can hear the interference, the ticking, so it's picking up something. That's full blast though. Let's turn down a little bit. Okay, 700 on here. Barely heard. Just barely, and that's a strong signal again. It should be blasting out of this radio. It should really be loud and clear. Should be triggering the AVC to quiet the set right down and just hear a nice clear tone. But boy, it's not doing that at all. Reception's terrible. Now, the next question would be, is it the alignment? Normally a radio like this is not way out of alignment unless somebody's fiddled with it. And they fiddled with it without instrumentation. And then it can get way out. Once it's out of fairways without instrumentation, really tough to get it back to where it needs to be. So that's in the realm of possible, but not likely. So we're going to try to find out. So I'm going to go back up where the radio works better. Actually, I'm just going to. Actually, you know what? I'm going to open the capacitor. Find a quieter spot. A quieter spot doesn't mean there's no signal being picked up. Clearly there's a signal there. But when you get to a quiet spot, there can be an unmodulated interference signal. And that's why the radio's actually getting quiet. But that's the best we can do right now. Okay, so I'm going to set the signal generator so we can pick it up again. We're on the dial, we're just below 1600. Really hear the garble sound. You hear the two different frequencies, 400 hertz, 1000 hertz. So clearly something's up. Almost certainly the weakness in here is not coming from alignment, but I want to eliminate that. So first we're going to tweak the IF just a little bit and see if things get better or worse. Okay, we'll start right with this one. Just kind of randomly pick one of the four. Okay, well, that was pretty close. I don't think there's a problem here. Well, any one of these I turned and the signal got less. So now we're going to try to find out what is the IF frequency. We're just going to try to pump it through the antenna. It's going to be 455 or somewhere very close to that. Not showing up at all. So sending the IF frequency in through the antenna is not really the best way to do it. So we're going to jack things up a little bit here. You can see the antenna basically is here. Here. Feed the signal in there. So we'll take this off here. I'm going to reduce this way down. We're going to stick a capacitor of some sort on here. I'm going to connect one lead to the capacitor and the other, I'm not sure what to do with it. We'll go on here. Assuming that's a good ground, that's not really the best choice. That's not the best choice. Better choice. Better choice would be, that's dust. Better choice would be maybe on the frame of the speaker. It's all bolted down solid, so we're just going to clip this on the frame of the speaker. Grounding to the chassis. Go on here. The radio's gone quiet because the output impedance of the signal generator is very low, and so I basically shorted things out. That's fine. We don't want to listen to that anyway. Now I'm going to try to put 455 or somewhere around there in here and hear it. Here we go. There it is. So you see it's very close to 455. We're going to go hunting. No. Hunting again. No. So 455 is the winner. So the radio is fairly well tuned in terms of the IF. Right frequency, they're aligned. But you can still hear the garble in the signal here. Not a happy camper. Well, these other alignment adjustments will not improve the performance of the radio very much. Not to the degree that we're looking for. So my conclusion here is that this is a sick puppy. He's not feeling well at all. Even when we feed a signal, let's try this. We'll advance the signal input from here at the antenna to here on this tube. We'll see what happens. So we'll leave that like that. Turn the volume down because we expect a little loud. We'll go on here. Previously we were feeding the IF signal through both of these transformers and this tube. Now we're just going to go through the tube and this transformer. Might need a lot more signal to do it. Same effect. say that this hum effect or garbling is occurring past this tube stage, past this transformer. Probably happening over here somewhere. So we want to stick an audio signal in. I'm going to do something, I don't normally do this, but why not? We'll try sticking an audio signal, and we can stick it right into the grid of this tube. It should come out of the speaker nice and clear. In the meantime, we'll shut down the antenna here. Quiet the radio. This is a bit of a long clip lead, but I'm sure it's going to work. So we're going to go on here and onto the chassis. Silence. Fantastic. Now, if we send a signal, I'll use my finger first of all. I better not use this one. Use this one. Into the grid here, we should hear it come out the speaker. There we are. We're going to send into the radio now a audio tone, a pure audio tone from this signal generator here. And we want it on audio, so we'll go down. Push a different button here. Megahertz, megahertz, kilohertz. Don't you go any lower? I went down too low. I think this is 700 hertz here. I think. Oh, I think it's 700 hertz. That's what it's saying here. It's in the megahertz setting. I want it. Hey, don't you know how to run your equipment? Kilohertz. That's better. 72 kilohertz. Oh, we're still way too high. 6,000 hertz. That's still too high. Going the wrong way. Just bear with me here a second. Let's go down here. 5 kilohertz. Okay, there we are. That's a little too high still. 5 is too high to listen to. 3 kilohertz. That's a very high tone. That's too high. 2. Okay, I'm happy now. We have a 2 kilohertz tone. It's going to be on the end of this. Okay, just to be safe, I'm going to try to clip this capacitor in here. Let's do this technique. Oops. Go. Same thing, we'll put the ground on the chassis here. Incidentally, this is a 5-tube radio, and you should have some concern about doing all these things I'm doing right now, except in this case I've got it plugged into an isolation transformer hidden way in the back, and this is also an isolation transformer, so I actually have two isolation transformers in series. That's probably not a good idea, but that's what I've done. Never gave me any trouble yet. We'll go here. Now I've got to make sure the output of this isn't too high, so it's low. And these are all the attenuators, so it's 0. We shouldn't really hear anything. Ooh, that's bad. Okay, so what that's indicating to me is this connection here is not going to work out. That I have to be connected to the B- circuit in the radio to do this properly. What I'm trying to find out is the garble coming from the audio circuits, or is it coming out of the RF circuits? So this is basically, this grid is the start of the audio. So now we want to get underneath the radio. And yeah, how to do that exactly? Or is there there won't be any B- opportunities up here. Okay, I'm going to have to tip the radio up on its side. basic shop practices. Never have the power on when I'm doing something like this. Okay, we'll tip it up this way. Okay, one of those wires is a B minus. A bunch of them are going to be a B minus circuit. Where are we going to find that? We will find that if we look at the volume control, which is here, and we look at the 3 terminals on the volume control. The center one is the audio. It's coming out and going through this capacitor here. And then we can see a black wire coming over and a capacitor connected here. And the other terminal is also a black wire. Shoot, okay, both black wires. So you really can't rely on the color of the wire in these radios. So I'm just following these wires to see where they go. If I can figure out which one is the B minus, I cannot. Okay, so another approach, if you can't do it with the volume control, we have to look at the circuit diagram anyway to be sure of that. We can go to the capacitor, which is here. That's where the wires are. Is it there for sure? Yes, yes. So down here will be a B minus connection, probably this big black wire here. It probably isn't quite good enough. Ooh, this doesn't feel very strong. Looks like I can see some guts coming out of this, some stuff coming out of the capacitor. So, big black wire. Where's that big black wire going? Big black wire appears to be heading towards the field coil. That would not be the B minus. Unfortunately, it's hard to tell which of these terminals is going to be the negative terminal. So I'm looking for now, if you look at this capacitor here, if you look right at the base of it, you can see there's a piece of material here. This is non-conductive material here, and you can see the capacitor is covered in cardboard. So you cannot contact the capacitor. The capacitor is up on top, up here, and you cannot make a contact to the capacitor. What this tells me then, I can look at this, and I can see one of the terminals, 1, 2, there's 3, 4 terminals, but one of them is obviously the shell of the capacitor. That's going to be the B minus. So now we can follow one of these black wires. You know what? It's the wire that goes to the back side of the volume control, or the contact that's farthest away. That's the B minus. Good. Okay. We're gonna hook up. What should I hook up? Hook up a lead or hook up like we'll leave the radio on its side, and I'll hook up this. Oh, I can't do it. I gotta be here. Well, maybe we can get at the grid underneath. Instead of using the grid cap, the wire for it is right here. In fact, the other side of this capacitor. So I have a couple options here. I can feed this signal right across the volume control, which is essentially what I'm doing here. And then use the volume control to control how much of this signal goes into the radio. The volume control will be active. So I put one lead on B minus, which is hard to get to there. It's a little dangerous down here because there's very high voltage. Well, 150 volts here. So let's go up here where it's just a little safer. Just kind of awkward. And the set is not on. There's no power coming over here. Okay, how's that look? Looks like I clipped it onto the wire itself, on the insulation of the wire. Get on there. Okay, that is on. It's not touching the chassis. these clip leads have a way of just wandered itself off. I don't like that clip. I don't like how that went. How about another spot? How about another spot? So we'll follow another wire from the terminal. There's one coming up this way, and it's very tricky to follow. It's connecting over here. What kind of connection can we make there? It's good and solid. Okay, that looks good. Okay, so we have the negative or ground connection. Now we want to connect to the audio input side of the volume control. And there may be a ADC voltage here, right here. I'm using a capacitor to keep it away from my signal generator. We clip that on there, and we're feeding audio at 2 kilohertz into the audio circuits of the radio. Are we set? Yes, we are. Here we go. Okay. Now remember, the radio is quiet now because I have a short on. We're going to have to remove the short here because we need to hear it to know it's working. Yep. Okay. And you don't hear the radio anymore. Hum when you turn it way up, but that could be this. We're going to put this on. Let's turn this up a little bit. Again, the output from the signal generator is nil, or as nil as it can be. I don't hear a thing. Now we're going to turn up the level on the signal generator here. Volume up. And you can hear it's also got that warble in it. We can take this down in frequency, can't we? We can take it up. That's about 1,000 hertz there. So whatever the problem is, it's occurring in the audio circuits, which would be the detector tube, audio amplifier, or the output tube stage, something like that. So I think that's where we'll start with this radio tomorrow. I'm finishing now for today. Tomorrow we'll try to get rid of this. We'll try to understand what it is that's happening and then get rid of it. That'll be the goal. So that sounds like fun. Fun and interesting things to do in your shop. To me, it's just not enough to just get in there and change all the capacitors and turn the radio on. I like to know a little more about what's happening. Try to learn. Try to extract a lesson out of these radios. Let me turn it off before I get a lesson on electrocution. And that's the approach I like to take, as much as I can. Okay, well, thanks a lot for watching to this point. And tomorrow we will attack the garble. Hey, sounds like some kind of movie. See ya.